Starting, all attendees are in listen-only mode.
Good afternoon, everyone. This is Tuesday, June 11th, and welcome to the next AEE member webinar. We have Mike Easton from QMC Metering Solutions for you today, presenting IoT and metering, making metering easy using wireless communications. But before I pass over to Mike, just a few things to get out of the way first. If you have questions for Mike during the presentation, please post those in the questions section of your control panel. If you have questions regarding audio or any other issues you might need assistance with on the technical side, please post those in the chat and I will chat back and forth with you to help resolve those. We will address most questions towards the end of the presentation. We may address quick questions during the presentation, but the majority will be addressed at the end. And Mr. Easton will share with you his contact information towards the end of the presentation. So if you do have any follow-up questions or wish to request a copy of the presentation, you may contact Mr. Easton directly to ask for that. You will also, all of those of you attending today will receive an email in the coming days, a follow-up email, as always, from GoToWebinar that will contain a link to the recording of today's webinar and a link to your certificate of attendance. So thank you once again, everybody, for being here today. I'm now going to give you just a little bit of background on Mr. Easton. So Michael Easton is the co-owner and vice president of QMC Metering Solutions for Easton, Canada. He manages QMC's national, commercial, and institutional portfolio accounts. Mr. Easton has been a partner with QMC Metering Solutions since 2006 and has spent over 10 years focusing on business development in Ontario, Quebec, the USA, and international sub-metering markets. Mr. Easton also works with utilities and energy efficiency organizations to promote the conservation benefits of smart sub-metering. Mr. Easton obtained his BBA from Simon Fraser University in 2002 and is a certified measurement and verification professional and a member of AEE. His previous employment includes BC Hydro Power Smart and BC Ministry of Water, Land and Air Protection. So, Mr. Easton, thank you very much for being with us today and agreeing to share your expertise with our members. I'm going to hand over to you.
Thank you, Sharon. Good afternoon, everybody. Again, my name is Mike Easton with QMC Metering Solutions. I assume everybody can see my screen now. And I'm also joined here today by my colleague, Neil Parikh, who's our manager of IT and energy management software. Today, we're going to be discussing wireless communications regarding metering systems. So IoT, big data, all the good buzzwords these days. But first, I want to start with a disclaimer, and that is that a lot of the systems that QMC puts together are hardwired solutions. So we don't do everything wireless. But we found over the last 5 or 6 years, the technology breakthroughs in wireless metering have allowed us to do more metering in more places and have really brought down the costs of those solutions, the abilities of them. And we're finding we're putting a lot more metering in place due to that. So what I wanted to do is I'm going to go over the agenda with you first. Okay. So we're just going to start with what we want to do, what we want to get from metering systems, the current challenges with some of the metering systems in the field, an overview of the complete metering solutions using wireless technologies, so more or less what we want from the systems and how we design them. We're going to focus in on 3 wireless technologies that we've utilized well in the last few years, including cellular, LoRa and Sigfox, and Modbus mesh networks. And we'll do case studies on each one of those systems as well. And we'll finish off with a question and answer period And if anybody would like a copy of this presentation, I'll have my contact details as well, so we can send that out to you. So just a bit about QMC first. We've actually been in business for over 20 years. We're actually at our 25th year. We service across Canada, and most recently we opened up a United States office in San Francisco. We supply multi-utility metering systems. We do electricity, water, gas, steam, and thermal meters. All the communications around that, software, billing, and related regulatory services. But please note, we don't actually manufacture any specific product. What we do is we find the best products in meter hardware, communications, and software from around North America, Europe, East Asia, South America, and combine those pieces of hardware and software into leading-edge metering solutions for our clients. And to date, we have about 150,000 meter points every day reporting in to our energy management platform. A lot of those, as I mentioned, are wired systems. We're seeing a larger proliferation of our wireless solutions these days. So one of the reasons metering is one of the metering is one of the systems these days that is not moved as fast as other types of technologies into the wireless world. And one of the big reasons for that is that metering is more or less a cash register. It's where utilities exchange hands between the utility itself and the end customer. And when that's happening, that's where they're exchanging money, essentially. So that information from the meter needs to be very accurate, very secure, private, come in a timely fashion, and also meet various legal and regulatory requirements. So if they're going to be changing anything within meters or adding modules to them to make them wireless, they need to ensure that they keep with those key qualities of a meter. Otherwise, you can end up with erroneous meter data, which leads to billing disputes, upset customers, upset operators. So it's very important that meter technology that's being used for metering, wireless metering technology is utilized well and vetted well before it gets put into the utility's use. Without that, again, these problems can occur. So that's some of the reasons that the larger utilities as well as meter manufacturers have been somewhat hesitant to implement these newer technologies that come out. But we're definitely seeing a larger use of them lately. And along with billing, the other things we want to do with good meter data are fault detection. So using that meter data to identify anomalies within a property, very similar to pinpointing problems. We want to analyze performance as well. So that's around measurement and verification. There's obviously preventative maintenance. So not only finding that low-hanging fruit first, but then ensuring that low-hanging fruit doesn't grow back. And there's obviously an increase in the amount of benchmarking and other programs such as LEED certification, ASHRAE, et cetera, that are requiring more metering to be done. So it's very important we're getting more meters within buildings, whether we're using it for energy management or billing purposes, benchmarking, et cetera. So here's some of the current challenges we're finding with meter systems. Often we come across properties that have a lot of metering deployed, but it is not being utilized. It's a stranded asset. So whether you've deployed electrical, gas, or water meters, they're actually just sitting there being manually read or not read at all. And it's unfortunate because that's usually a pretty good meter. If somebody's taken the time to supply that meter and to install it, and in the end, it's just not being utilized. So what we want to do is try and utilize that existing hardware if possible. We often come up across what we call incomplete projects, which are the meter system's been deployed, maybe it's been wired together or has a wireless solution, but it hasn't been fully integrated into an energy management platform or a billing system, so that it has been commissioned, integrated, maybe the data hasn't been validated, and once that happens, the meter system tends to not be utilized in the end and again goes to waste. We often find that meter systems are proprietary, and that's one of the challenges that's been historically with a lot of the wireless systems available in the market, is they have been proprietary systems. And once that happens and you're not able to utilize that data and share it with a variety of other groups who might need it, like fault detection software, energy management platforms. There's obviously a lot of metering in the field that is manually read. And when you have a manually read meter system, unfortunately, you're not getting interval data from that. It's very inefficient and time consuming to go out and read those meters. And there's often errors occur when you're pulling that data and during the manual process of that. And lastly, we come across a lot of systems that, albeit the meters might be working okay, they have a lot of legacy technology in them. One of the ones that we're trying to remove from our portfolio is pulse meters is a good example, where instead of getting a register read from the meter that identifies the exact consumption on a meter, we're relying on pulse data that can be tampered with or lost in transmission. So even though the system's kind of working, it's not giving us the full potential of the meter system that we're looking for. So one of the things we want, or some of the things we want meter systems to do once we move to a wireless or an integrated solution, is connect to those stranded assets, utilizing hopefully third-party modules or modules provided by the existing meter manufacturer that allow us to wirelessly or wired connect to those stranded assets, those stranded meters. We want to provide a turnkey solution as well. So not only supply the meters, but do the project management and commissioning of those meter systems, and then also tie those the meter hardware into an energy management platform, billing platform, etc. We're also aiming to move away from proprietary systems, and I'll actually elaborate on that in the next slide. Obviously, removing manual processes by putting wireless modules on some of these meters allows us to not have to go to the meters anymore and gets us interval data from those systems. And wireless technology, again, hopefully we can upgrade those existing meters, if not replace them, so that we're not relying on older communications protocols. I just wanted to take a little bit of a note here on proprietary systems, because it's probably one of the biggest shifts we've seen in the industry over the last 10 years. One of our largest customers, an international commercial property manager, in about 2010 told us to stop supplying anything that was proprietary. They wanted any meter that was going into their building to be open protocol. At that time, they wanted everything Ethernet enabled, so that way they could access their meters, or any organization they wanted to be partnered with them could access their meters without any special software or need to reach out to the manufacturer for service offerings. And what that is really allows for the end owner of the meters to have better contract terms. They're no longer roped in with that manufacturer to read their meters for the lifetime of that system. They're able to switch service providers, either for energy management software, billing, or any other services they need utilizing those meters. And that way you can also export that meter data to any third-party group who wants to receive it. So lately we've seen a lot of fault detection software coming on to the commercial property world, and we've been those fault detection companies have been able to access the meters very easily because they're on open protocols. So this graph here, or diagram, shows kind of a holistic view of a metering system. And when we design a metering system, we really want to look at three key components. One is the meter hardware itself, which is obviously located within the building. Two, we have, or the second tier is the communications infrastructure, which is what we're going to be focusing on today with wireless communications. And then three, kind of on the right here, is some type of software component that is coming along with the meter system, so that the data you're collecting from the meters and over the wireless communications is going to be used for something good. Most solutions these days are going web-based. We offer a web-based solution as an example, and we also partner with numerous other web-based energy management software companies. And the reason for that is that your data is no longer residing on a server. I could spend a bit more time going over that at the end of the presentation if we have time. But obviously from that software, you're doing everything from billing, alarming, leak detection, and it's usually available to all the different stakeholders within a building, including operators, accounting, energy managers, etc. I'm just going to take 1 second here to read a question that came in, please. It's a good question. So the question that came in is, if you have a proprietary system, can you make it non-proprietary, or do you have to remove that system completely? I'm just going to go back to this slide. It's a bit dependent. Some of the meter manufacturers that have proprietary systems are able to put an additional gateway or a module or modify their front-end software to allow the data to be opened up, essentially. So they can collect everything, all their data on a proprietary protocol, and then open it up with something like BACnet or Modbus, or even push the data via FTP to any group who might want to receive it. Some, though, are locked down. And if they're locked down in very old systems and the vendor is unwilling to, quote unquote, open it up, then you might need to look at replacing that system, unfortunately. But whenever possible, it's great to integrate with those solutions, open them up, and move forward. It obviously saves a lot of costs and removes all those extra hardware and labor requirements. Thanks for that question. So when you're looking to do a wireless solution, here's some of the requirements that need to be considered before you pick the exact technology you're looking to utilize. The first thing is the frequency of data collection. So a lot of times we hear, we need real-time data, we need real-time data. And very few of our customers actually utilize real-time data, especially when they're doing just doing billing, or if they're doing basic energy management, not instantaneous energy management. So if you don't need real time, it saves you a lot of costs, as well as opens up the opportunities for wireless communications a lot. Often we're finding the standard for a lot of the battery operated wireless solutions we're utilizing are collecting interval data, but just transmitting it once per day. Seems to be the industry standard at this point. If you do need real-time communications, often you need to go with a powered solution, not battery, or a wired solution. What measurement parameters are required? If you're looking, let's take electrical meters as an example. If we're just looking for kilowatt hours or possibly demand, it's a whole other data requirement, or easier data requirement than if you need harmonics, power factor, instantaneous demand, etc. Then if you need that, you need to factor in additional communications requirements. Are the meters going to be used for billing, or are they going to be used for just energy management purposes? And not only does that change your communications requirements, but it also changes the meter availability. If it's an energy management meter, you can pretty much use any meter in the market, whereas if it's for billing, obviously you need ones that meet with your regulatory standards in your region. Is there a battery required, or is power available? So if you're going to be installing a water meter somewhere on irrigation, it's going to be very difficult to get power to that. So you're going to need a battery solution. If you're going to be using electrical meters, there's usually power available too, so you should be able to avoid a battery solution. Number of meters. So in case of, sometimes you're only looking to meter 4 or 5 points on a site, all the way up to a smart city where you might be looking to do 30 or 40,000 meter points. That obviously impacts the communications option you're going with. The distances and distribution of meters. So are you looking at all the meters confined in one building, and there's a few hundred of them, or are you looking at meters scattered all over a campus or even a small town or a city? And obstructions, what kind of line of sight do you have, will obviously play an impact. Is the meter located in a basement? That obviously impacts your communications as well. Which software and platform will the data go to? That might also limit what meter manufacturers or communications protocols you can go with. And lastly, is there space or a location for a local gateway, or will be part of a larger smart network? So examples are, sometimes you're doing a townhouse development, there might not be space for a local gateway in a common area, so you might need to go with a cellular solution in that case. So the 3 technologies we want to look at today are cellular or LTE, LP WAN, so low power wide area network, and we're going to look at lower end Sigfox options for that, and wireless Modbus, which is going to be more of a site-based solution. And we've utilized all these with pretty good success, and so we wanted to share some of the case studies for those. So I'll just start high-level overview of cellular. Obviously, it utilizes the existing cellular network, and over the last several years, the cost of utilizing cellular networks for low data uses like metering have gone way down. So now that we're utilizing LTE and LTE-M networks, the costs are a fraction of what they were a few years ago, making cellular-enabled metering much more cost-effective. You can get down to 15-minute resolution quite easily. And usually, as I mentioned earlier, we're usually doing daily updates of the data, so collecting in 15-minute intervals, but pushing to the system once a day. And the reason for that is that allows the battery life to be maximized, and the solutions we're using these days are actually a 20-year battery life. We typically use these with a variety of different meter manufacturers, so the cellular solution we have is very flexible with different manufacturers. It obviously allows you to get better economies of scale and retrofit existing metering portfolios. And obviously, along with billing, a leak detection function is one of the best things we get out of these systems. With the LoRa and Sigfox networks, you can integrate various utility meters and sensors all on one platform. So it's not just utilized for metering, but for other smart city applications, and that's allowing for lower costs of deployment because you're sharing that with all the different sensor types. We're getting either hour data resolution, or you can even move that up to 15 minutes. And you can choose whether you want hourly updates or daily updates from the system. Depending on the meter or on the module manufacturer, you're looking at around a 10-year battery life. And one of the great things of the LoRa and Sigfox system is an incredibly long range, available anywhere between 10 and 20 kilometers. Obviously, we utilize that for leak detection and billing and smart city applications. And lastly, the wireless Modbus solution. This is nice because it doesn't have any network fees. You're essentially deploying a gateway on site and utilizing wireless Modbus devices to create a mesh network. Everything is powered off the main, so there's no battery power. So once the system's up and running, it should be good for the life of the metering system. It's a self-healing mesh network, so if one of the modules is unplugged or is damaged, the communications will still regulate itself back to the gateway. And the other nice thing of the Modbus solution is there's more parameters available. So because we're not worried about frequency of data and the size of the data packets we're sending, we're able to get more parameters out of the meters, such as harmonics and real-time amperage and voltage, etc. We're typically using the wireless Modbus network for electrical metering solutions. I'm just going to take 1 second here to go over a few questions that have come in. So it says, how can we deal with the cost impact since wireless-based meters are very costly? We've actually found that the cost of wireless metering has been going down significantly over the last few years. It's dependent, obviously, on some of these things we're bringing up. But if you are looking for very basic meter data, so hourly intervals, not a lot of other measurement parameters, and you can utilize it in scale. So it is expensive if you're only doing 20, 30, or 40 meters, but if you get up much above that, we find that the solutions are very cost effective. But maybe that's one I can take into a little bit more detail at the end of the discussion. Obviously, if you are able to utilize existing meters as well in the field, which is something we've had a lot of success with, especially if it's a more open protocol meter, or you've brought on a wireless option that is able to adapt to these meters, you're saving on the cost of the new meter, and you're saving on the labor of installing that meter. So you're really just paying for the module and any connection fees from that moving forward. That's definitely one of the better ways we've found of saving costs. And the next question, what kind of batteries are used for these systems? Usually lithium batteries. Thanks for the questions. Okay, so we're going to focus first on the LTE solution. So as we can see here, you're essentially putting a cellular module on any one of the water, electrical, or possibly even gas or thermal meters located in residential or commercial properties. That's sending a signal back to the nearest cellular network tower, and then that is pushing data over the cellular provider's backhaul and eventually to a web-based energy management software. We're primarily using it for commercial and standalone home applications. What's nice about it is it's usually non-proprietary, and it integrates well with both new and existing meters. We're currently on LTE networks. We're moving towards LTE-M in the near future, and it just seems that there's more and more, there's increasingly lower costs available on cellular networks. So we find this is just a really easy technology for us to be promoting to our clients lately. So the good example we have of a system like this is for electric utilities. It's the utility outside of the Greater Toronto area, and it's actually the second largest privately held or publicly held utility in North America. They had a variety of water meters in a variety of different building types, which they were trying to automate. They were currently using a drive-by solution, which obviously was costing them a fair amount to get to those sites. They were doing it only monthly, so they weren't being able to adapt to mid-month move-ins and move-outs. They were not getting interval data off the system. And lastly, when they did go to site, often they weren't getting great communications to the meters, especially those in harder to reach areas like the middle of condos. So we deployed for them cellular modules onto their existing meters. So it was a quick retrofit, going in and just wiring it into their existing meters. And we're able to pull data on an hourly basis in 50-minute intervals. We have a 20-year battery life on the system. And to this point, we have approximately 2,300 units deployed for them. It's been a very successful deployment. The costs were low. The data reliability is very high. And we're very happy with the system so far, as are the customers. We're actually deploying it for them in other jurisdictions for them across the country. The other nice thing with this solution, as I just reminded, is there wasn't a change to their billing system either. So once we were able to collect the data on our web-based platform, we were able to send it over to their existing billing system via API, and we were able to build that into the data format they wanted. So it looked just like the data they were getting from their previous drive-by system. Secondary case study I wanted to do on cellular tower metering was and just shows the flexibility of a cellular network. We have quite a few cellular providers across North America, and one of the things they need, they often rest their equipment on another owner's tower. So they have to rent space on a tower that more or less acts like a landlord-tenant arrangement, and a meter needs to be put on that carrier's equipment so that they're being billed by the tower owner for the electrical consumption they use. So you obviously have a metering network now spread out across a country, so very hard to put any other solution in place. So what we're able to do is put an electrical meter that either has a cellular module added to it or a cellular meter or a cellular modem built under the glass of the meter, and that communicates obviously very easily to the cellular network that's on that tower, and then back to a web-based EMS and to a billing system. So it's essentially a plug and play where you're moving an old glass meter, an old dumb meter, putting in this cellular-enabled smart meter and putting the data back online. Some considerations are that meter does need to meet the local utilities or the local region's requirements for billing, and depending on what jurisdiction you're in, there's various regulations for that. But the cost of doing this, for the hardware, for the labor, and the data is all very reasonable. It's been a very successful deployment for us. Just going to take 1 second to answer a few questions here. So the question is LTE going to become obsolete in the near future? We believe LTE will be here for a while. 3G is still around. We expect and so we expect the LTE network will be here for at least the life of our meters. The telcos have made very large investments, and they won't want to remove that existing infrastructure. All that said, we want to stay current. So the most recent systems we're looking to be putting out, new hardware we're bringing online, is LTE-M. And the second question is, what is the manufacturer of the water meter? We're not going to be promoting any specific brand today of meter manufacturer, but I'm happy to take that email after the presentation and provide some options. We're also, there's probably 3 or 4 different water meter manufacturers we'll touch on today, as well as 3 or 4 electrical meter manufacturers that you'll see illustrated here. Because again, we work with a lot of the different, a lot of the leading manufacturers from around North America. So moving on to LoRa and Sigfox, or LPWAN systems. So these systems have really come into being in the last 3 to 4 years. They have really started in Europe, and that's where we got really involved with LoRa, was from one of our European manufacturers. It's really part of the smart city network, where water meters, gas meters, electrical meters, along with parking sensors, temperature sensors, humidity sensors, garbage can sensors, etc. Light sensors are all integrated onto a LoRa or Sigfox network. And what's beneficial about these networks is not only that you get to utilize these other existing networks or the infrastructure put in place for them, which helps bring costs down, but the range available to these systems is fantastic. You get anywhere between 10 to 20 kilometer range. We feel it's ideal for large unconnected properties or smart city applications. So where we're finding it is in townhouses, single family homes, and even irrigation opportunities. We're primarily utilizing it for water metering right now, but we might be utilizing it for gas and electrical in the near future. Our favorite case study on this is actually out of South Africa. You might all recall that South Africa has been going through droughts, especially in the last 3 years, where it got very critical, especially around Cape Town. One of our partner groups there needed a wireless technology to connect to a variety of remote location meters, primarily on residences. And so they deployed a Sigfox system and onto the water meter of their choice. We then collected that meter data back on our Meter Connects platform, and then pushed it back to this organization for billing purposes, as well as a direct interface for the residents, because they actually had a maximum threshold of water consumption they could do during this drought period. So not only were they being billed accurately for it, which is one financial incentive to conserve, but also they were given this data to say, hey, you utilized 3/4 of your accepted water for the day. You better turn off the tank because you're going to hit a very expensive threshold moving forward. Along with that, cost incentive and information incentive, they're also able to do leak detection on the system. So this just shows, and I apologize, it's very small on the bottom, but you can see cold water and hot water consumption for a unit going for pretty consistently for about half a month at the bottom left of the graph. And then the cold water consumption just started to skyrocket. And that was obviously a leak in the system. As you can see, once the customer was made aware of it, they reduced their consumption back to normal levels near the end of the graph. If that interval data wasn't available, or somebody was doing a manual read on that meter once a month or once every 3 months or even once a year, like is quite typical in a lot of residential applications, there would have been a lot of water wasted, and they did not have the ability to waste water in that scenario. And this is just an example of continuous leak detection that is done, where essentially if we're collecting all of this data, we're able to look through every water meter and determine if it's never hitting 0. And that can identify, as you can see here, and send an alert to whether it's an operator or utility, a billing person, an energy manager, whomever it is, if there is any consumption, or always at least a minimal consumption on a water meter, which usually indicates some type of leak. And you can see this one's even down to 1 liter an hour. So obviously there's a very small leak there. This one's down to 5 liters an hour, so it's still a small leak. This one here under the building called the factory is about 32 liters an hour. So it gets quite expensive if that's happening every night, overnight, when nobody's even utilizing water. And the last solution we want to dive into is the wireless mesh network utilizing Modbus. But I will note it can be used with other communications protocols as well, including BACnet. We typically use this within commercial buildings or campus solutions. You can get several floors of penetration, so it has worked very well for us in high-rise applications. And it's usually an add-on module built onto a meter, but sometimes you can build it, or it can be built right into some meters. What's nice about this is it's typically mains powered, so we can use it in real-time monitoring scenarios, and we can utilize it with to get multiple measurement parameters. As I mentioned earlier, it's primarily being used for electrical metering right now. The diagram here essentially shows all of the endpoints in green, how they communicate back to a few central repeaters, and then pushing to a few gateways on site. If one of these repeaters does fail in the end, the endpoints will find another repeater to send their data to. And whether you're utilizing repeaters or the meters communicate to each other in a mesh, there's a few different options for that, depending on the manufacturer of the product. So this is an example of a project we did where for Toronto Community Housing, they needed to not only utilize existing meters they had at site monitoring key loads, but they wanted to retrofit in meters and meter every one of the tenants within the space, or residents, I should say, within the buildings. We did quite a few buildings for them. So I'm going to start on the bottom here, in which case we integrated with some existing meters utilizing Modbus onto a gateway. And this gateway also brought in the Modbus wireless mesh network from the rest of the building. So the front end wireless device connected directly to that data logger, and then communicated in a mesh network to all the other wireless mesh devices on site, which were wired in on a Modbus network to the meters in their specific electrical room. So there was approximately, I think the largest one of these we did was about 450 units, all reporting via wireless mesh network. One of the challenges we had was that the meters were located in electrical rooms every few floors, and it completely encased in concrete. So a lot of the other wireless solutions we wanted to utilize didn't work, and as well a wired solution was also not possible without very expensive coring. So we had to find a good solution in this and this one worked out very well for us. Again, it's a self-healing network, as mentioned. So if one of these devices does go down, the rest of the system doesn't go down with it. The devices just find the best route back to the data logger. All the data then is collected and pushed to a website EMIS, web-based EMIS, and then pushed to a billing system from there, as well as an energy management platform. And from there, we had two kinds of meters, some reporting on the mains. So what we can see here is a high definition profile down in 15-minute intervals, not only the kilowatt hour consumption of the meter, but also the power factor. And they're obviously doing energy management of that, understanding when their building is using load and when, and they could drill down to a variety of other loads, other key loads of the property. And then also they're able to break out all the different tenants within the floor or across the entire building and identify high-use tenants in those areas and engage them, not at billing at this point, but with energy conservation measures. So what we wanted to do is, before we get into questions here, is just summarize some of the things we discussed. So we've looked at how some of these wireless technologies have helped us overcome some of the metering challenges we've come across. No matter what solution you're going with, you do require somebody who understands the existing metering hardware, the new metering hardware, and what the end goal of the customer is to develop the wireless solution. It's typically not something you want to just buy off of a website and install. It's usually best if a meter system integrator or building automation company, controls manufacturer, etc., or an energy management team are able to deploy this on behalf of the property, or at least design it. In the end, we're aiming to increase the level of customer service, lower the cost because we're not doing manual reads anymore, and improve the performance because we're getting good interval data. We're pushing that to web-based platforms, and we're doing things like leak detection and anomaly detection from there. And use tools such as a dedicated EMIS to react to problems faster and create a better use case. So I guess one of our key messages here is that no matter what meter you put in, no matter how you communicate with it, if that data doesn't go to somewhere good, whether it produces a bill, sends out a leak detection report, or finds some type of anomaly or sets off an alarm, it's really not a completely cost-effective system. You're not getting the value out of it. So we always want to ensure that the data is going somewhere and being utilized. In the end, we hope this will help you guys recover stranded assets, build on your existing systems, provide non-proprietary systems, eliminate manual data entry, and improve your return on investment from any meter system you deploy. And if you'd like a copy of the presentation, I'd be very happy to send you one. And if you have any further questions beyond the ones that got asked, please type them in now, and myself and Neil will do the best to answer them. I'm waiting for a few questions to come in here. Just wanted to show one last graph, which is the utilization of wireless technologies in institutional settings. So we have done quite a few projects lately where we are utilizing on a hardwired network the building's existing networks, their IT infrastructure, but we're also complementing that with cellular, LoRa, or other mesh network solutions on more remote buildings within the campus, because they might not be set up in the same way as the rest of the campus. And this is really happening mainly in the military bases, where we've got a lot of IT infrastructure in some of the larger and more modern facilities, but the outlying structures really don't have any information IT infrastructure. And so we're just deploying cell modems in those locations or other wireless technologies to bring that data back to the main building automation system. One other thing we should probably mention is the data from these systems is very secure, whether it's being utilized primarily in a cellular network. The data is encrypted there, and in most cases it's on a dedicated APN. So it's all secure, and the meter or the cellular devices themselves are not able to be remotely accessed by other parties like they would be on a public IP. So I've had a few questions come in here. Can we obtain a soft copy of the presentation for reference? Thank you. Yep. So if you want to email me, my email address is mike@qmeters.com, and I'll gladly send that back to you upon receipt. There's two questions on that. One other question is, can you give an indication on typical cost? So is it like a 20 to 40 meter system versus a 40 plus system? So not sure what jurisdiction this person is asking the question from, but I'll assume the interest is around water meters. Just taking a stab at that. If it's on others, please send me another question on that. In that case, you're usually looking at somewhere under $100 for a water meter, usually under about $200 for a gas meter. And yeah, the question came in, it's for all the utility types. And depending on the size of service, probably somewhere under $200 for the electrical meter. A typical wireless module, depending on the type, can go anywhere from $50 all the way up to about $250 for some of the cellular devices. And again, this would be dependent mainly on battery life, but also the communications options and what you're integrating with. Very low cost options are out there for pulse-enabled systems, which, as I mentioned at the beginning, we're trying to avoid in the future. And then when you get into the more encoded register options, they are a bit more expensive. And then dependent on what solution you're utilizing, your front-end costs will vary. So if you're utilizing a cellular solution, you're your costs are really the installation of the cellular module and then a monthly fee for utilizing the cellular network. And that's got anywhere down from, anywhere from as low as 50 cents a month up to about $3 a month, depending on the amount of data you're using for small amounts of meter data. If you have lots of meters reporting to one cellular module, then it usually costs more because you're sending more data. But in the kind of this IoT solution, it's about anywhere between 50 cents to about $3 for that per meter for that communication. On LoRa and Sigfox, Sigfox has more of an upfront cost, which you need to pay for their modules, whereas LoRa is an ongoing monthly cost, very similar to the cellular solution, for that LoRa network to collect your data on and then push to you for then your billing or energy management software. And then lastly, the wireless mesh network, you're probably looking at about $2,000 upfront for the front end gateway, as well as the wireless modules for that front end and the installation of it. And then the wireless modules are usually around $100 a piece, depending on the manufacturer. And those, because they're a Modbus network, they can tie into multiple meters for one Modbus module, one wireless Modbus module. So you might be able to have 20 or 30 meter points connect to just one Modbus module and then push back to the gateway. I hope that answered your question. And any of these questions I'm not answering to fully, please feel free to email me and I'll gladly take another stab at it. Another question came up, is the system support available globally and can it be installed in any region? Yeah, it is available globally. So I gave the one example of the Sigfox deployment down in South Africa. Admittedly, our boots never touched the ground in South Africa. We sent the modules down that way, and we remotely integrated with the service partner in that region. So really what you need to look out for on the regional basis is what communications are available there. So if you have a LoRa network already existing in an area or a Sigfox network, you're going to be really easily able to utilize that network, or you could set up your own micro LoRa or Sigfox network with the installation of your own antenna. Cellular capability, it's really anywhere. I mean, pretty much anywhere on the planet right now, there's cellular networks available. So if you're working with a cellular provider who has a good roaming package, you can literally send your cellular modules anywhere you want in the world. And wireless Modbus, you'd probably want to look at what the common protocol is in the region you're working with. So MBus, for example, is utilized very extensively in Europe. Modbus and BACnet are used extensively in North America. There's a variety of different protocols that might be utilized, so you just want to make sure you're sending or designing modules in that utilize those regional protocols. Oh, the quick question, what is IoT? The Internet of Things, just high level. The idea that as we move into a more integrated and open communications economy, that more sensors and other devices in the field will be integrated into the internet utilizing wireless communication. So, excuse me, the example of a water meter being located in an irrigation pit somewhere far away from any wiring abilities, you'll be able to put a module on that and communicate back to a few towers within a city that are collecting, in this case, LoRa meter data, and that'll be provided back to the billing company or the energy management company. A question came up. Do you have experience with installing sub-meters in older buildings with multiple commercial retail units? If so, were there any challenges working with older buildings? So we do have a lot of experience with that, and that is quite a common challenge. You'll go into an existing, let's call it a 10-unit strip mall, and they have 10 meters in place. They're all old glass meters or maybe CT-rated meters, current transformer rated meters. We would need to look at those meters, determine if they have, let's say, a pulse output or some other communications option available to them that we can then tie a wireless module into and extract the data with. If you come across those meters and they're just dumb meters, there's nothing you can get out of them, they unfortunately do need to be replaced. But what you do try and do is utilize some of the existing infrastructure. For example, if it's a typical glass meter that's located in a meter base, you will continue to use that meter base. You'll just remove the glass meter and put in a new smart meter. If there's existing current transformers for a meter, we can utilize those current transformers just with a smart meter head. And then from there, you're looking at what type of communication is best to get that data out. Is it cellular? Is it LoRa? Is it wireless Modbus? There's a variety of different options out there. And there is often challenges, but in a scenario described here, it shouldn't be completely, there should be a workaround for it. And if you have a portfolio of 50 buildings that all have a variety of existing metering, there won't be a one-size-fits-all solution. You'll need to look at 2 or 3 of these different solutions across your portfolio. And that's why I mentioned in the previous slide here, you'd probably want somebody who's very familiar with metering and these communications options to go and select one for each site, as opposed to buying a solution for a portfolio and sending it to each of those 50 sites, because it's not a one-size-fits-all, and some of those systems will work and some of them won't, and you'll just have upset operators and building managers who don't have a complete system. So it's best to customize for each property. Another question, is there a cost to integrate the sensors into an existing EMIS platform? Yeah, it's really dependent on the energy management software provider. If they have worked, for example, our business has worked with a lot of different modules and meter manufacturers. So if we need to integrate, let's say it's a census water meter, which we don't actually sell, but we integrate with, we can pull that data in fairly easily because we've already integrated with numerous of these meters in different properties. If it's a new meter that ourselves or other groups who do integration haven't worked with, there might be a one-time setup cost to integrate that meter, because you need to work with the manufacturer to understand their protocol, how you'll receive the data, try that out in a quick pilot program, test the data, validate that it's all coming in accurately and that it does that consistently for a few months, and then put that up on your system and, quote unquote, pass the solution. Then that would probably require a bit of a setup cost if they haven't done the integration yet. And that's why it's nice working with some of the larger integration companies, because they have integrated with numerous meter manufacturers, so there shouldn't be too many models out there that they haven't done some work with. Next question, what type of metering currently, So what kind of metering that is currently not communicating remotely might be upgraded in the near future? Yeah, so probably the dumbest metering systems out there are gas. I'm sorry if there's any gas utility people on the line, but typically water is being so electrical meters were the first to really go wireless. Water was next, and BTU and steam meters are not really plentiful enough in the field right now to necessitate a lot of custom wireless solutions. So we're pretty much seeing gas being the next one that it's going to adopt, either probably LoRa or Sigfox solutions or some other proprietary wireless communication out there. Gas is dominated by a few large manufacturers who are all slowly building their own AMR opportunities or solutions. But I do know, because there is so many gas meters in the field, call them third-party communications options like LoRa, Sigfox, etc., are looking at deploying our solutions for that as well. Because almost all gas meters are used for billing, very much like my earlier slide, they are going to be slower to move because they don't want to do something that's going to interfere with the current accurate read provided by that meter, and any regulatory requirements around that meter. But I would say that's probably the next one you're going to see really expand in the amount of AMR being done with that utility. Next question, do you have any experience getting near real-time data from commercial buildings in Chicago with 40+ meters? Yeah, not in that specific city, but definitely across, not far away in Toronto, we've done numerous integrations with existing meter systems to get real-time data out of commercial buildings. A lot of the main high rises in the city we've done integrations with. yeah, it depends on the exact manufacturer that's currently there. If you have basic pulse meters in, for example, the EMON-DEMON system is very used widely in the US. It might have pulse outputs, which you can integrate those pulses into a front-end data logger, and then get out a near real-time solution or even a real-time solution of that. If you have BACnet-enabled meters on site or Modbus-enabled meters, it's very easy to get a real-time solution out there, either wired or wireless, and as per the wireless case study we just did a few slides ago. What types of trash, recycle, compost metering do we have experience with? We actually, admittedly, don't have a lot of experience in monitoring of waste and other materials. We focus on utility monitoring, so electrical, water, gas, BTUs, steam, condensate. So I apologize, I don't have a lot of experience to comment on there. Okay, well, there's, I don't see any other questions coming in now. I'll wait another few minutes in case any more do come in, but we are getting near the end of the allotted hour. If anybody does have any questions they want to send me, again, my email address is mike@qmeters.com. As I mentioned at the very beginning, we do have a U.S. representative as well who's very happy to answer any questions, and I can forward on any information or region-specific questions to them. Oh, there's another question here. Can submeters be directly linked to the building DDC or BAS system? And the answer to that is yes. One of the, pretty much where most meters started being integrated to was the building automation system. And that was done either by pulse output or other opportunities like 4 to 20 milliamp or Modbus or even more recently BACnet. Our one challenge with integration to the building automation system is you need to ensure it's a building automation vendor who is very interested in integrating that meter data, so that they do not only integrate and correctly get the data in, but that they're also logging it. A lot of building automation companies are happy to see real-time connection to the meter, but they're actually not trending that historical data, which you want to then use for billing in the future. What we're finding now is that most of the meter systems existing in the field, the electrical meters, are on a separate platform from the mechanical meters, water, gas, BTU, which are then tied into the BAS. So we're trying to integrate with those building automation systems to get that mechanical meter data into the same platform as the electrical meter data. In the end, the customer wants to go to one place to get all their meter data. They don't want to go to one software for their electrical, another software for their thermal, and maybe the BAS for their water and gas. So it's very important to try and get all the meter data onto one platform. And if a lot of that data is already going to the BAS, that's great. You just need to do an integration with that building automation system, and hopefully they can push you the data, or you can put another data logger on site that talks to the meters and doesn't interfere with the BAS's communication with the meters. I hope that answered your question. Question is, and this is a good one, I am frequently challenged on the return of investment on metering. Can you tell me how you measure the ROI of adding metering? Since there will be capital expenses. Yeah, so great question, and this is a challenge that a lot of metering companies, energy managers, anybody who's looking to legitimately put a metering system into a property comes across. If metering, and I mentioned this maybe about 10 minutes ago, if metering is put in and it is not put on some portal or some location where the data can be used for at least energy management, and if ultimately billing as well, then it is going to be a harder return on investment. So we always encourage, like, the easy return on investments for metering is systems that are used for billing. If you bill residential or commercial tenants for water, there's usually anywhere between a 10 to 30% decrease in their consumption. If you meter them for electricity, it's about the same. Gas is a little harder to get that same return on. So on tenant billing metering systems, the return on investment is very quick. On energy management systems, it's a little bit harder to justify because you need to ensure that somebody's utilizing that meter data to go find anomaly readings. So why is this lighting panel on 24/7 when it should only be on for 12 hours a day? Or why is the HVAC system running when it shouldn't be? Meters can show that, and you can set alarm thresholds to tell you that, but unless somebody takes that data and goes and acts on it, it's not going to get you savings in the end. So you really need to ensure that the team who's going to be utilizing or is going to be in the building with the meter data is going to utilize that meter data. We've had, I'll be very upfront with this, we've had lots of examples where companies we work with have done great work with metering, especially on the monitoring larger critical loads within the building. So irrigation systems, data centers, chillers, boilers, etc. And often the best meters you're going to get on any system are the main electrical, the main gas, and the main water, because they show you the whole building profile as opposed to drilling into really small subloads. There's a lot of metering companies out there that will also tell you to meter everything. So go down and meter every 15 amp or 30 amp circuit. And I'm not going to lie to you today, I think that unless you're going to bill a specific tenant with that meter point, I think that's going too deep. We usually want customers to meter the larger loads that they as operations teams and energy teams can act on, and then meter any load that you can literally bill a tenant or a resident back on as well. Outside of that, metering 15 amp lighting circuits, I don't think you get a good return on investment from that. I couldn't sell you it. So I hope that answered your question well.
Okay, I think we're going to round it up there. We're just about a minute or two over our hour, so I would just like to switch back to my screen just quickly. I would like to say, first of all, a huge thank you to Mr. Mike Easton and his colleague for your presentation today. Lots of good questions, and I'm sure more people will continue to follow up and email you with further questions. But we truly appreciate your time to present to our AEE members today. And for those of you still with us, just a couple of quick reminders. We do now have our CEM online training, and we have others following pretty soon, so please keep a lookout for those on our website. You can see the web address on your screen right now. We also have our biggest event of the year coming up, our conference in DC in September. That's AEE World Energy Conference and Expo. We hope to see some of you there. And then just a quick reminder that we do have another member webinar coming up on Thursday, the 20th of June. That will be with Jennifer Fortenberry presenting best-in-class corporate energy management programs. So hopefully many of you will also join us for that. So thank you once again to Mr. Mike Easton and to everybody else for attending our webinar today. Hope to see you all again soon. Bye for now.